right now we want to do what we have done for the Z board in other video in the zybo board right now, which is getting started with Zynex Vivados and generate the hardware configuration necessary for the application. You can use the SDK to light a LED connected to the processor, and also you want to make sure that whenever you trigger one of the switches to the on position, you will be seeing that on Vivado. You see the LED on the top will be power on as well. So in order to do that, you'll be sending a C code to our processor on the board. It will communicate it through a peripheral with your GPIO, which will get the values from the switches and pass them to the LEDs. And we're going to do some logic here when you program that whenever half of the switches are on, you're actually going to see another LED be power on your board. This is just to indicate that you have a processor reset which is low asserted, which might be causing you troubles ahead when you're doing your VHDL codes or your Verilog codes. So keep that in mind, that your processor reset is actually low asserted. So how is Zynex 2 is going to do that? You're going to go to Vivado. That's the first program from Zynex that you're actually going to use, and then you're going to create a hardware. You're going to create a hardware configuration files. Then you're going to export those files after you design your hardware in Vivado. You're going to export them to a folder, and then you're going to launch your software development kit to program your processor, to target your processor with the C code. And in the SDK, you're going to create also a board support package to target the processor with the peripherals available. In that case will be the LEDs and the switches. And once this is done, we're going to create an application project that links all together and allows us to debug and run the developer code, and also make sure that we can use the console to do the debug and the run as well. So that's it for this presentation, and right now I'm going to create a new project here. I'm just going to close this one. It's going to take a little while. So we're going to create a new project and call this zybo demo. RTL project. Here you can choose the target language. I'm more comfortable with VHDL, so we're gonna keep this, but you can also use Verilog if you feel like using. I don't need to add existing IPs or constraints here. In here, just go for board and zybo board. If you download the definitions, as I'm gonna put in the link description. So finish what you have done here. You see there's a project part zybo, which is XC7010 COG401. That's your chip available on the board. So in here we're going to create a block design I'm going to call this one zybo demo as well. Once this is done, we're going to add the Zinc 7 processing system block. You're gonna run the block automation. It's gonna fix the I/O here. You're gonna put some output on the DDR as well. And right now, what we're gonna do is add an AXI GPIO to use the LEDs and the switches. So in here, right-click this. You're gonna actually double-click. Sorry, double-click this. You go to IP configuration here. You see that you can enable dual channel. So I don't want to add another block of AXI GPIOs, so we're going to add a dual channel on this one. So you run the connection automation here, just trigger this for a while, AXI S_XII. So you hit OK, and Vivado will do some connections for us. I like to regenerate your design here, and I like to put this one on the top. The reason why I'm putting this one on the top is actually to illustrate something that looks like our presentation, where you have your processing system, your processor reset, and AXI peripheral, and your AXI GPIO here. So this is kind of how the things are connected together. What we want to do right now is actually, you see this tab with board components here. You see there's a system clock, buttons, LEDs, and switches here. you can actually use those three in the GPIO as it has a folder indicated. So just let me check which one we're gonna use in the channel 1, because it's quite important for C code. So we'll be using this code here, and in here you can see that you have set data direction as 1 to be, and then the channel 1 is actually inputs and the channel 2 is actually outputs. So what we want to do here in Vivado is you want to use the channel 1 as inputs, so you put your switches first and your channel, okay, and you want your channel 2 to be your outputs, which will be the LEDs. So you can regenerate the design if you want, validate the design. This is quite important, it will help you to find errors and this kind of stuff. So validate is complete, that's awesome. So right now what we want to do is go to sources, right click here, you want to create a HDL wrapper, and you let Vivado manage the wrapper and auto update. What Vivado will be doing is he's going to create a HDL code that describes everything that you did here, all the connections and all the inputs and outputs. You can double click here if you want to see. You can see there's a lot of stuff here that Vivado does automatically for you. And there's also a component, say zybo demo, which is your block design. So here's your top level. So right now we want to save our project and we want to run and generate the bitstream file. Once this is done, this takes quite a while to do. If we have no errors on the end, we'll be able to export our hardware and launch SDK and continue our program. You see there's the address editor here. If you click here on data, you'll be showing addresses of important connections that you have made before. Just let this window here go away and then I'll be able to move. So if you see here, you get your XCGPIO and you got a base name which is rag, and all you have is an offset address, a ranger, and a high address. So I think I'm gonna stop the video right now because this takes quite a while to be done, and I'm gonna show you the message that you should be getting in the end. So if you follow the steps correctly, you should be seeing this message at the end, and you're gonna open the implemented design in here, and you'll be able to see what the design looks like on the board. So here's your implementation design. See those blue dots here in the middle, and what we need to do now is file, export the hardware, and include the bitstream because you're using the FPGA right now. And right now what we're going to do is launch the SDK. Everything's local to project. I don't like to change this, I think it's not the best idea ever. So I'm gonna cut the video right now because it's quite long, but in the next video what we'll be doing is learning how to use the SDK in order to target your processor. So this will be the homepage for the very next video.